Right. Okay. Well, my name's Stuart Jones, and I'm one of the directors of Durham Energy Institute. Nice to have such a group for today, nearly 30 people coming to listen to Dominic Emery or Dom. Um, if I can just give a little bit of housekeeping before I formally introduce Dom today. If everyone can just keep the microphones switched off and the cameras off for the course of the presentation. Normally we ask questions at the end, but Dom has specifically said he'll probably want to be a little bit more interactive during the course of the session, and that's absolutely fine. We can, when Dom stops talking and asks you to ask questions or wants interaction, please turn on your mics then if you want to ask something. Thank you very much, Dom, for joining us this lunchtime for the presentation. And as everyone can read, Dom was the former Chief of Staff and Head of Strategy at BP, presumably based in Sunbury, were you?
I spent some time there,
Yeah.
but quite a lot of time in the head office, initially in Britannic House and then over in St James's Square.
Brilliant, brilliant. And Dom's going to give us a talk today, which is going to be really interesting to have it from a perspective of former BP employee on how we deal with climate change in this energy transition, especially when we're thinking about oil and gas strategies and their importance. And of course, many of you have been aware of the recent government's change in plans to maybe put some more tiebacks around some of the North Sea oil and gas exploration, and I no doubt that will be also a topic of conversation at some point. So, but without further ado, thank you very much, Dom. I'll leave the floor to you to carry on your presentation. So, thank you.
That's great, Stuart. Many thanks, and many thanks to you all for being on the presentation this afternoon. As Stuart mentioned, what I'll do, I will go through a couple of slides and then kind of invite questions and thoughts from the audience. So please feel free to fire away in the usual raise the hand way or stick it on the chat. So just by way of background, as Stuart mentioned, I was formerly at BP. I retired from BP 3 years ago, and during my time there, I worked as a geologist. In fact, one of my former colleagues is on the call, Professor John Gluyas. So John and I worked together quite closely on various aspects of reservoir quality back in the day. 10 years as a geologist, then 10 years in a more sort of commercial environment. And then the latter kind of 10 to 15 years was primarily involved in low carbon, the energy transition, working initially for BP's new alternative energy business that was set up in 2006. And then I spent some time running the corporate venture capital unit, which is essentially the internal venture capital unit that spends BP's money on exciting new kind of startups, and many of those were in the energy transition. Then I moved to the other end of the telescope, and I was head of strategy for BP at a pretty challenging time after the Gulf of Mexico tragedy, where really it was more of a kind of survival strategy. But then we did start to advance more towards low carbon from around 2018 through to 2020. And at that time, a new CEO came in, a guy called Bernard Looney, who wanted to really transform the company in a very profound way for us to lean into the energy transition, to commit to net zero. And at that time, I was I was chief of staff and working with the senior team and trying to make that happen. As you'll probably be aware, that has not been a successful strategy for various reasons. I'll go into that over the course of this presentation. So that's just a little bit of background on myself. Currently, after leaving BP, I took on a number of board roles, working with a big offshore wind company, a smaller advanced biofuel startup, an EV fleet company, and a predictive maintenance company. At the same time, I also do some advisory work and work with a number of voluntary kind of organisations promoting the energy transition and promoting acceleration of that energy transition. So with that, let me go on to the first slide. Now, some of this stuff you will be very familiar with. Climate change, it's society's biggest challenge, and mitigating climate change is frankly impossible without a profound energy transition, which is one of the topics I'll go into. And that simple fact seems to be getting lost in the kind of extraordinary geopolitical times in which we find ourselves, where nationalism and populism and short-termism continue to trump the so-called tragedy of the horizon. And that is a kind of a simple term, which really means that climate change is, because it's not a kind of a near-term matter that we need to attend to, although try telling that to people who have been impacted by extreme weather events, the collective effort to make the change is still not as fast or as deep as it needs to be. So a few kind of factoids. Again, I suspect most of you are familiar with this, but the last couple of years were the warmest years on record. 2025 is likely to be approaching that. And several months in those last 2 years have exceeded the iconic, if you like, 1.5 degrees C versus pre-industrial level temperatures. And the rate of change is about 65 times faster than we've seen in the fossil record. And that's kind of really important because the Earth is seeing these kind of, obviously the Earth has seen kind of absolute temperature changes, both colder and warmer than we're seeing at the moment, for sure. But the rate of change is extraordinary. And of course, back in the day when we were seeing ice ages, etc., we didn't have 8 million co-inhabitants on the planet. So historically slower rates, geological kind of timescale rates, allowed more time to evolve and adapt, and also more time to equilibrate, particularly through kind of weathering of rocks, which is normally on a kind of a 10,000 year kind of timescale. And of course, we simply don't have the time or ability to cope with those challenges. And if climate change goes to the kind of extreme end of the spectrum with kind of 3 to 4 degree rise, that will probably cause about the migration of 10%, so 800 million people on the face of the planet, from soon to be uninhabitable parts of the planet. So sadly, you probably expect nothing other than unmitigated kind of pessimism about our ability to slow or reverse global warming. And I think it's true to say there's virtually no chance of making it to kind of net zero by 2050. But human ingenuity is such that we still do have some chance of making the Paris goals. If you recall, the Paris goals that were laid out in 2015 were to keep temperature levels to well below 2 degrees and to strive towards 1.5 degrees. I think 2 degrees is going to be super challenging, but certainly the last COP, when the COP in Brazil did the kind of the tally up of all the nationally determined contributions from the different countries, we're probably heading more towards 2.8, 2.9 degrees. So the kind of the worst case of 4 to 5 degrees that was kind of laid out maybe 20 years ago is probably not going to materialize, but nevertheless, it's going to be extremely challenging. So that kind of sets the kind of the tone. Warmest years on record, several months exceeding 1.5 degrees, and the rate of change is faster than anything we've seen in the fossil record. There's one thing I probably should add to that, because a lot of the time kind of we're measuring temperatures on land, but some of you may be familiar with kind of oceanic temperature measurements, which pretty much since May 2023 have been breaking kind of daily records for any particular time of year. And in some cases by quite significant margins, so 0.3 degrees centigrade. It doesn't sound a lot, but that's extraordinary in terms of kind of changes from one year to another. And of course, some of this is attributed to certain oceanic oscillations, notably El Nino. That's now kind of gone away, and it won't be accelerating temperature rise quite as fast. But nevertheless, we are seeing lots of kind of natural change, including in the marine environments with a new wave of coral bleaching, and of course, many extreme weather events on land that I guess we're becoming all too kind of familiar with. So I'll stop there. That is the deeply pessimistic part of the presentation, and I'll go on to some optimism in a moment. But very happy to take any questions about that and any of your observations and thoughts. Right, okay. Well, in that case, let's move on to something that's mildly more optimistic. And you kind of think, well, how come you're talking about emissions if you want to move on to something that's mildly more optimistic? Well, looking at the picture for emissions, at first sight, they continue to rise globally and are now at an all-time high. Very likely that by the time we get into the end of this year, we'll see emissions that are kind of approaching the kind of the totemic 450 parts per million. So emissions in total are about 55 gigatons of CO2 equivalent a year, and you'll be familiar with what causes those emissions, primarily CO2. Secondarily, kind of methane. So methane is a very important near-term greenhouse gas forcer. And then other kind of lesser gases, but nevertheless important, like kind of various kind of nitrous oxides, for example, and some other gases that are also responsible for kind of ozone layer depletion. But the main, if you like, culprit is combustion of fossil fuels. And combustion of fossil fuels accounts for at least 70% of CO2 equivalent. So that does include CO2 directly and also includes methane. Energy emissions from fossil fuels last year were about 38 gigatons. So that's very significant. But energy emissions in 2024, so here's a slightly optimistic bit, only saw a rise of 0.8% as renewable power has grown versus a GDP growth of 3.2%. So historically, what happened is that the kind of the rate of growth of emissions was very much tied to GDP, but now we're seeing GDP growth far outstrip emissions growth. And in fact, in advanced economies, we're now seeing emissions that are back at 1973 levels. And of course, many of you will be familiar with the situation in the UK, where emissions are actually down at kind of levels not seen since kind of late Victorian times, since the kind of the 1870s. So there are some reasons to be optimistic. So basically, we're seeing the rate of emissions growth slow down, primarily as a result of renewable displacement, so low carbon electricity displacement of traditional fossil fuels. A couple of other interesting kind of anecdotes in terms of renewable growth. The rate of growth in Chinese renewable deployment has been extraordinary, and that means that solar and wind are expected to overtake coal for the first time over the course of this year, making up more than 40% of total installed capacity in that country. It is another extraordinary point that China installed as much solar capacity in 2023 as the entire world did the year before. And something like 60% of all the investment, which we'll get into in a minute, in low carbon is actually coming from China at the moment. And the Chinese government has made a very kind of serious and significant commitment to emissions reductions, expecting emissions to peak in the coming years and then start to decline. Now, again, as you'll be aware, the Chinese kind of economic growth was very largely based on the back of coal from about 2000 through to kind of 2020. Coal growth was very significant. That growth is slowing down, but there are still coal plants, albeit much more efficient plants being built. But nevertheless, in the end, economics is kind of proving its worth because the generation of electricity, albeit intermittent, from solar and from wind is now way cheaper than the generation of electricity from fossil. So the Chinese government are seeing this and are creating renewable development at scale and are also building the world's largest factories to churn out solar panels, to churn out batteries, and also wind turbine generators. So that's a little bit about emissions. A few causes for optimism there. Again, happy to leave it and take any thoughts and questions on what we're seeing vis-a-vis emissions at the moment. Right, I'll move on to the next slide, which is really all about kind of energy transition pathways. There's one kind of overarching and simple point, which is if we want to make the energy transition successful, we have to commit to electrify everything we possibly can. So that electrification represents 60 to 70% of end use by 2050. Just to put that into perspective, energy end use by electricity is now about 25%. So that's a way to go to get to 60 to 70% end use. But electrification, because electrification can be done by low carbon, clearly solar, clearly wind, biomass, and nuclear, and there are other kind of smaller sectors like kind of tidal and wave. But nevertheless, the substitutability of fossil electricity generation by renewables is extraordinary. That's precisely what's kind of happened. And the scale of what's happened has allowed the cost of that electricity generation from renewables to plummet significantly. But that's not everything. The remaining 30 to 40% of low carbon energy will need to be provided by low carbon or offset liquids and gases. So this could be fossil fuel generation with carbon capture and storage. This could be through the use of hydrogen. This could be through the creation of e-fuels. This could be through the creation of biofuels at scale. And all of those remain possible, but all of those, to a greater extent, are pretty expensive at the moment. And so the electrification journey will probably happen much more quickly than the journey towards e-fuels, advanced biofuels, etc., etc. And what you can see on this slide here represents three different kind of scenarios. So on the left-hand side, and this is from the BP Energy Outlook that gets published every year, and it's well worth a read because it does talk about energy transition and energy in relatively kind of, I think, not necessarily kind of simplistic terms, but in very sort of clear terms by kind of by only taking, if you like, one variable at a time. And what this chart shows, the left-hand side, is that the net zero scenario, which is the kind of the blue line, if you look at the right-hand side chart, you can see what the final consumption by fuel will need to kind of look like as we get towards that net zero scenario by 2050. So that's the column that's represented by clearly the lowest final consumption, the highest proportion of electricity, the vast majority of which is generated from renewable sources. The other important thing to share with you about this particular chart, if you look at the actual final consumption of energy, which is in exajoules, which is on the y-axis, you can see that that's about 30% less than the consumption of energy in 2019, which is the kind of the marker year. So that requires huge amounts of energy efficiency in the system. And this is something that I still think is really, really challenging. This is something that the IEA, the International Energy Agency, have been kind of pointing out for years, that if we truly want to kind of migrate towards a low carbon energy system, it's actually essential that we use less energy. Now, in the current environment, that's particularly challenging because we're seeing huge amounts of energy demand and energy growth as the population continues to grow, number one, even though a lot of that is becoming increasingly efficient. But we're also seeing a huge demand for electricity through data center growth spurred on by artificial intelligence. And some statistics have suggested that that growth of data centers is going to contribute to something like 5 to 6% additional CO2 emissions, unless it's done with low carbon electricity sources, which is the intention for the majority of data centers. Although with the current kind of political climate in the US, I think that's going to be very, very challenging. So there are really 2 points I think to summarize on here. Number one is energy efficiency, and the reduction in final energy use through efficiency means is going to be mission critical. And secondly, widespread electrification is really going to be the only way to get to net zero by 2050. Okay, so I'll stop there. Very happy to again take any questions or any kind of any thoughts on that before moving on.
Hi, Dominic. Could I ask a quick question? Hi, it's Tessa. I just wondered what your views on nuclear are, given that that's a political hot potato also.
Yeah, absolutely, Tessa. So nuclear fits into that kind of purple column. So it's low carbon electricity. And I would say nuclear, interestingly, was a hot potato, and the potato has become quite a lot cooler in the last few years, particularly in the UK, notably with the developments of a couple of very large kind of traditional kind of nuclear reactors of the kind of 1 to 4 gigawatt size, albeit it will still be expensive. And frankly, traditional conventional nuclear has been very challenged. The second one really is the advent of what's called SMRs, small modular reactors. And this is a technology that's been developed by Rolls-Royce and Westinghouse. But the idea of small modular reactors is that instead of being the kind of the 1 to 4 gigawatt scale of traditional nuclear, these are 200 to 300 megawatts. And they're sort of built like Lego. Now, that's not to kind of underplay the complexity of it, but the idea is to build these at a much smaller scale to allow you to develop learning curve effects and reduce costs. And interestingly, in China have been building out 1 gigawatt nuclear plants for the last few years. And the learning effect that China has got from building out 1 gigawatt plants has meant that the cost of actually building them has gone down dramatically. So I think the cost associated with nuclear is still high, but as an important baseload contributor, both as conventional nuclear and small modular reactors, I think they're going to play an important part in the energy transition. They're not going to be as important, certainly in the UK, as offshore wind, which is going to be the real kind of backbone electricity provider, and to a lesser extent solar. But in other countries like France, which went nuclear in the mid-70s as a response to the oil crisis, I think they'll continue to play a very significant role. Thanks, Tessa. Any other questions before moving on?
Dom, I'm going to Stuart here. I'm just going to play devil's advocate here for you, in the respect that I can see that there's definitely a drive for electricity, and that's really important. But it also seems to be, when you're speaking to the wind farm companies and other electricity generators, that there's a very large pushback from understanding kind of the social aspects of this. In many respects, the wind farm companies can build their wind farms quite effectively, but actually trying to get the grid connection is particularly challenging for them. Putting the electricity infrastructure in across the UK is certainly having major pushbacks across many communities. So how do you see that going forward?
It's an absolutely brilliant question, and totally germane to this kind of whole challenge, and particularly in the UK. So I think the likelihood is that wind will continue to be developed with greater speed offshore. The onshore wind ban that was brought in a few years ago, there may continue to be some smaller onshore wind developments, which is still quite a kind of cheap form of electricity generation. But it's less about the generation. It's much more about, as you described, the infrastructure and grid connections. Interestingly, last week, the government just published a kind of a white paper to try and accelerate grid connections and to accelerate infrastructure development by taking the so-called kind of zombie projects. This was the official term, apparently, zombie projects out of the kind of the queue for grid connections, which should free up a lot more kind of space for kind of larger projects to come into the queue. So as a result of the government's commitment to decarbonising the electricity grid by 2030, which I still think is a big, massive challenge, I suspect it won't happen, but they're certainly going to try. The zombie projects going off the list is kind of one thing that's going to be happening. And the acceleration of infrastructure, as you described earlier, and we'll see in a moment, at least a third of the total cost of the transition will be required into infrastructure, both transmission systems, distribution systems, storage systems, and efficiency systems. So, and that is causing a lot of public outcry near where sort of I live in East Anglia. There are real challenges in building connections from the southern North Sea across into London. There are big grid connectors that are required to come from Scotland down into the north of England, so from areas of generation to areas of use. And of course, that's appearing on energy bills at the moment. A very significant proportion of energy bills is made up of a green levy and also of the infrastructure bill that's required. A lot of people are kind of blaming high energy prices just on the kind of the marginal cost of gas, and gas is a big contributor to it. But nevertheless, until we put this new system in place, it's very difficult to see how energy bills are going to come down anytime soon. So there's going to be some short and medium term pain, both in terms of bill costs and in terms of public outcry for infrastructure development. So it's a huge challenge, Stuart. And I think the government are starting to understand the scale of that challenge by taking zombie projects out. But the infrastructure objections are going to be significant.
Okay, thank you, Don. Okay,
so moving on to the next section, which is more around the kind of the cost. And of course, having just mentioned cost, the cost of this transition is going to fall primarily. It's going to fall primarily on the consumer, but the opportunity in, let's say, the sunlit uplands in the years to come is that if you can imagine an electricity system that's delivering electricity at effectively kind of zero marginal cost, because you've built the infrastructure, both the generation and the distribution and the transmission infrastructure. There's no cost of fuel because wind and sunlight is free. So you get to a very interesting point in the future where, in theory, electricity bills will be super cheap. So the bias of investment for the clean energy transition, so wind and solar, etc., etc., it's quite an interesting kind of it's quite an interesting number. If you were to generate a certain number of gigawatts through wind and solar generation, about 70 to 80% of that will be capital, and about 20 to 30% will be kind of ongoing operational. If you did the same through gas-fired generation or coal-fired generation, about 20 to 30% will be capital, and about 70 to 80% will be ongoing cost, which is primarily fuel costs. So it's a very, very kind of different kind of investment flavour. So it does demand a very high upfront sort of capital investment cost. So broadly, and I'd take these numbers with a bit of a pinch of salt because they do get, frankly, they get higher every year. Every year we don't make enough investment. The next year becomes higher. So around 3.5 trillion a year of capital investment will be required to make the energy transition happen between now and 2050. You'll see plenty of other numbers. You'll see others saying it's more like 7 trillion. Other numbers will say it's more like 10. I think this is probably towards the kind of low end of the spectrum. But this is the cost, or others may see this is the investment opportunity. This is probably the biggest, if you like, purchase order in history. 3.5 trillion to convert the energy system. So where are we today on that? Well, we are certainly not at 3.5 trillion, but actually we're better off than many commentators would expect. We're investing about 2.1 trillion per annum today on the energy transition, and that's up from 1.7 trillion in 2023. So we are making progress. And as I mentioned a bit earlier, about 60% of that is in China. Now, of that, about 70% of that investment is required for low carbon power generation, transmission and distribution. And as you can see from the chart on the right-hand side, about half of that is going into generation, about 1.3 trillion, and about 1.1 trillion of that power sector investment is going into power networks and power storage and grid flexibility. So just to kind of reiterate the point I made a little bit earlier, electricity is kind of very much kind of where it's at to make the energy transition successful. And as Stuart pointed out, the transmission network, storage and grid flexibility are going to be super important. But actually what's quite interesting, certainly from the experience of kind of Germany, is that I would say about 10 years ago, the expectation was that because of the intermittent nature of renewables, wind and solar in particular, then you'd never be able to have anything kind of more than about 70% of intermittent kind of renewables on the grid at any one time. The reality is for a country the size of Germany, where you do have kind of weather systems distributed up and down the country, actually the reality is that the amount of kind of storage and grid flexibility that's being required is much lower than anticipated. So you can get high levels of renewable penetration without requiring kind of balancing activity at scale. And this has become, I think this is kind of a learning effect, which has come as quite a great surprise. Now, nevertheless, that doesn't mean to say that batteries aren't important. You're probably familiar with battery projects that have been developed up and down the UK. At the moment, they're the size of about 100 megawatts, but there is talk about developing kind of 1 gigawatt batteries, which gives you short-term but very significant electricity storage. And there's also grid flexibility that will be provided on the demand side. You're, again, familiarity with electric vehicles, the possibility of storing power in your car battery and then feeding it back to the grid. Nissan are just starting to allow that to happen in the next year or so. So I think there's going to be, in a sense, some positive unintended consequences of all of the storage that gets created in a distributed way in our vehicles, and also from households having batteries to manage their solar panels and to manage their own power generation. So that's a little bit about electricity. I think on the other side, on the right-hand side of the diagram, you can see the other kind of costs, the balancing kind of 1.1 trillion that's going to be required into buildings, into transport, into carbon removals, and the developments of clean hydrogen and clean industry. They are very significant numbers, but they are not at the scale of electrification. Now, electrification will actually feed in to a number of these different opportunities, including kind of renewable heating, including heat pumps, which is a very big push for the United Kingdom at the moment, and also underneath that, road charging infrastructure, which again in the UK is growing. We also see aviation and shipping. Now, for aviation and shipping, it's highly unlikely that we'll be able to kind of electrify in totality unless there's some massive breakthroughs in battery lightweighting and battery and charge duration. So the probability is that aviation will move to things like sustainable aviation fuel, and that will require, essentially that's a liquid hydrocarbon, which in molecular terms looks almost identical to existing jet, but is formed through either as an electrofuel, which is probably not a technology that will kind of arrive in quantity until the 2040s, or as some form of biofuel. Similarly, shipping, apart from very short-haul ferry trips, will likely, long-haul shipping will require liquid fuels. I think shipping is more challenging in some ways because it's not obvious which direction shipping will go. Will it go the biofuel route? Will it go the electrofuel route? Will it go the hydrogen route? Will it go the ammonia route? Will it go the green methanol route? And a number of the more kind of advanced shipping companies are now starting to trial and run dual-fueled engines, which could fill up with traditional shipping fossil fuel and also green methanol. And then the final kind of section is made up of kind of carbon removals. You've got John Lewis, Prof. John is on the phone, and John has done on the call. John has done a huge amount of work on CCS. The UK offshore is absolutely ideal for carbon capture and storage, and you're probably aware of a couple of big projects that have been announced. One in the North Sea, the Northern Endurance Partnership, which is a very big store in a bunter sandstone in the southern North Sea, and then also storage in HyNet on the west coast, which is probably storage in exhausted gas fields around Liverpool Bay. So I think CCS will be important, but it isn't a silver bullet. And in all probability, of the 50 or so gigatons of CO2 emissions that are currently being emitted, CCS may be able to deal with about 10% of those, so perhaps 5 gigatons. And it may be that natural climate solutions, such as the development of forestry measures and others, can deal with about 10 gigatons. But that, at the moment, is an industry that I would say is quite challenged, not least because of challenges around kind of permanence, forest fires, and accounting. So an engineered solution like CCS, I think, will be super important. So that's a little bit about the cost of the clean energy transition. 3.5 trillion a year of capital. It will be focused on the development of infrastructure for sure, particularly electrification. And we have super big challenges on the future around carbon removals, around aviation and shipping. So yeah, happy to take any questions on that. Right, I'll move on to the next slide, which is really a little bit about, having set the climate change context, the emissions context, and the kind of oh, Catherine, far away.
Hi, sorry, yes, it's Andy Applin has just put a question in the chat. He says he can't talk because he's in a public space, but he said, any idea how much was and is being spent on coal to oil and gas transition? How does that compare to the 3.5 trillion per year needed for the oil and gas to low carbon transition?
So for coal to oil and gas transition,
Yeah, how much was spent on that transition, or how much is still being spent on that transition, was Andy's question.
So I would say the pace. It's a good question. I probably won't be able to give a number, but the transition from coal to gas, so coal-fired generation to gas-fired generation, in the UK has been extraordinary. As we know, we've now got one of the lowest emitting kind of power grids on the planet, which is fantastic, and that's largely been a result of closing all coal-fired generation in the UK. And I would say that the cost of doing that has been probably relatively kind of modest. And the reason for that is some of these coal plants are coming to an end of their useful life anyway, and would have needed to be replaced. So we're probably talking of the order of hundreds of billions as opposed to kind of trillions here. The other question was more about coal to coal. Was there a question about kind of coal to? No, maybe it wasn't a question about coal to liquids, but I think coal to gas has been very successful in some geographies. But there's a big but here, and the big but is that there are many countries in Southeast Asia where coal is relatively cheap. So places like Vietnam and the Philippines and other nations are starting to burn coal at a rate that is kind of surprisingly high, given the nature of the energy transition. So coal is still in the system, but as you saw a few slides back, coal needs to be largely out of the system by 2050. And if it's not out of the system, then CCS has to apply, or it has to be offset by some other form of natural climate solution.
Claire, do you want to go next?
Hi, thanks, Stuart. Hi, Dominic. We seem to be quite good at showing figures for upfront capital costs and what's required to do the transition, but I don't tend to see it reflected in when we look at what emissions might be going on over the period to 2050. So there's obviously associated with those capital costs is emissions as well. So what I mean is often I think this is right, it tends to be in the modelling and forecasting that you would amortise that emissions cost associated with the capital over whatever the lifetime is, I think. So, but rather than reflecting when it occurs. So given that we're possibly facing tipping points in the system, I just wondered what your view was on that. I hope that makes sense.
Yeah, I think so. One particular important point, and I would say this is a point that's made by objectors to the energy transition who are kind of saying it's a hoax. I can't imagine who that would be. Talking about the amount of carbon that's kind of required to construct the facility in the first place, and is that more than the carbon that they save subsequently from displacing oil and gas, from displacing coal, etc., etc.? And the answer is absolutely. A lot of people say, well, electric vehicles, they cost, there's a lot of carbon invested in electric vehicles to build them. Well, actually, that's true. But as the grid gradually becomes decarbonised, the actual cost of the carbon intensity of the manufacture of the facilities or the cars or the offshore wind farm, that goes down dramatically. And in any event, even in a relatively kind of carbon intensive grid, the amount of carbon involved in the building of the kit is de minimis. It's 10%, maybe 20% absolute maximum compared to the emissions that the kit will actually going to save subsequently. So the way the accounting works, to be frank with you, Claire, the accounting rules around climate change are still in the dark ages. One group that I do quite a bit of work with is looking at how do you change accounting rules to incentivize investment in low carbon. Because at the moment, there is no incentive. We're just using double entry bookkeeping in the same way that we've used it historically. There is no recognition of externalities, which is the externality being that we're seeing kind of climate change kind of right in front of our noses, and we're seeing emissions rise. So my view would be kind of watch this space in terms of changing the rules around carbon accounting for capital investments, seeing those investments less as liabilities and more as assets on your balance sheet because of the commitment you're making to carbon reduction. So accounting rules need to be changed and changed profoundly if this is going to be successful.
Thank you.
Okay, I'll just move on to the next slide, which is probably fairly germane, given that we just finished yet another COP in Brazil, which by any kind of stretch of the imagination was not successful, which is a shame, because the excitement that was generated around the Paris COP in 2015 was considerable. The commitments of kind of countries, in some cases, became legally enshrined, like in the UK and a few other countries. But global leadership around COP has been, it comes together occasionally. The Glasgow COP was quite successful. Even Abu Dhabi was relatively successful, particularly given it was the CEO of ADNOC who spoke about the energy transition. But fossil fuels is they've just been left out for reasons, and countries that we know about being left out of kind of COP communiques. And yet fossil fuels are the biggest contributor to climate change without a kind of shadow of doubt. So there's more teeth that needs to be added to the COP process. Exactly how that happens is challenging. The stock take process, so that stock take is countries have made a commitment to things called nationally determined contributions, which is how much they're going to reduce their emissions by. That becomes a kind of a ratcheting process every 5 years. So if you're not making your commitments, then you kind of get ratcheted up to make more progress in the coming years. And I would say the COP process is it's the only one we have, which is multilateral global process, because this is obviously a multilateral global problem. It's far from perfect, but at least we have it to try and at least put pressure on some countries that are laggards. The next thing on the next bullet point was something that I just mentioning to Claire, was around changing accounting rules around net zero. I think that absolutely needs to kind of happen for this to be successful, and actually for net zero commitments to actually materialise and be recognised on a company balance sheet. And at the moment, they are not done so in the way that they should be. The other is around understanding green premia, who's prepared to pay for that. It's an interesting group of companies that have kind of set themselves up as the first mover coalition. So these are companies which have a particular commitment to reducing emissions and are committing to buy products, green products, be they green aggregates, green electricity, green fuels, all of which require, in some cases, a kind of a higher price than the fossil equivalent. But these companies are saying, I think that about 20 billion has been committed so far. And in so doing, they might be able to kind of scale the deployment of green aggregates and green fuels so that the price starts to come down to meet traditional kind of fossil fuel prices for some of these high value and more challenging products. Stuart asked the question a little bit earlier about scaling infrastructure. Again, the permitting and conditions that allow that to happen, they still need to be massively accelerated and improved. But the challenge is planning processes still require public consultation, and some of those consultations are taking a huge amount of time. And certainly this government has, not to everybody's taste, I would say, has said, look, we're going to take kind of decisions into our own hands. Public consultation processes will happen, but they'll be kind of reduced, and a few individuals won't be allowed to hold some of these projects to ransom. A couple of other areas. One is these multilateral development banks in developing countries. Again, these are things like the African Development Bank, a bank that used to be known as European Bank of Reconstruction and Development back in the 1990s. Some of these can actually start to use kind of finance, so risky finance, to accelerate kind of projects whose economics are at the margin. And I think particularly in developing countries, to prevent them from kind of locking into the kind of to fossil fuels, this is really quite essential. But we are seeing some real signs of progress because solar is now so much cheaper than fossil, and the infrastructure required for solar panels and indeed wind is so much simpler than that for fossil. We are seeing developing countries start to leapfrog over traditional kind of fossil energy deployment, which is quite exciting and interesting, and that's happening particularly in Africa and also in some parts of Asia. And then we have GFANZ and private sector finance. And GFANZ is a long-winded acronym for the Glasgow Financial Alliance for Net Zero. This was a kind of much trumpeted alliance of pension funds and insurance companies, which have something like an extraordinary kind of amount of sort of assets under management, 130 trillion, they were proud to say. But unfortunately, it's had a slow start, and the promise of redirecting even a modest percentage of all of this capital into low carbon sectors to help de-risk and to help accelerate has not happened at the pace that anybody would really like. Well, not anybody, but certainly those committed to the energy transition. This was trumpeted very much as part of the UK's COP in Glasgow a few years back. But unfortunately, because of kind of the current political climate, a lot of banks and a lot of insurance companies and pension funds are kind of rowing back from that, which is a potentially huge source of kind of finance. I mean, it's 1 and a bit percent, 1.3 times global GDP, which is pretty enormous. So they're the kind of policies and actors. That's kind of what is needed to kind of happen at the kind of the large scale. I think what I'll just do now, before moving on to a quick kind of oil and gas company case study, is just to talk a little bit more about the kind of the costs and the cost of action, the cost of inaction. So going back to a couple of slides, I spoke about the cost of action and the cost of reaching net zero by 2050 being of the order of $3.5 trillion a year. That's about 3% of global GDP. So that just puts that into perspective. But the cost of inaction and uncontrolled climate change, depending on what sort of temperature we get up to in the coming decades, could be between 19 and 59 trillion in the next 25 years. And that doesn't include the kind of the terrible human toll of migration of these 800 million people if we get to very kind of severe uninhabitable parts of the world. So kind of many years ago, this was back in about 2003, 2004, Professor Nick Stern, who's at London at LSE, spoke about the cost of action being a relatively kind of small percentage of global GDP. And the so-called Stern report, which I still think in its essence it should be hugely influential, did say, act now and you'll kind of save trillions and trillions in investments and in frankly adaptation later. But that's the kind of that implored message has kind of fallen on kind of deaf ears, and we're still sadly in a much kind of shorter termist environment. So the cost of inaction could be between 19 and 59 trillion, whereas the cost of action, call it 4 trillion a year. So I'd just kind of be thoughtful about that when people say, well, let's wait. So with that, that's my kind of overall sort of global kind of summary of climate change, what's happening from emissions, what's happening in terms of investment. It's mainly not good news, but there are some sort of glimmers of hope. What I wanted to do now is just to kind of talk a little bit about the strategies of oil and gas companies over the last few years in the last kind of 10 minutes or so. But before I do that, very happy to take any more kind of generic questions before going into this in this part of the presentation.
Dominic, could I ask one question quickly,
yeah, of course.
please? It's Tessa again. I just wanted to ask your views on critical minerals and the scale of the need to harvest critical minerals globally, and the impacts that that's having and going to have. And yeah, I'd be interested in your views on that.
Absolutely. So critical minerals across the kind of the electrification agenda, in particular, the likes of uranium, copper, lithium, nickel, and there are others besides. There are rare earth elements, for example, for kind of magnets for wind turbine generators, and a whole raft of more sort of complex kind of minerals required for batteries, or a complex set of elements required for batteries. I think the answer to that is, Tessa, is clearly the kind of this in a world that's concerned about the energy transition. It would be disastrous for the social impact of large-scale kind of critical mineral mining to become a kind of a social bad. And we are seeing some of that in certain parts of the world, particularly in cobalt mining in DRC and indeed elsewhere. But the mining companies are adopting a much more kind of socially responsible approach to critical mineral extraction. There's a lot of geopolitics associated with it. As you've kind of seen, China is the biggest refiner of rare earths, and that's got the US in particular pretty scared, although they have reached some accommodation, it would seem, around that. I think the other big factor here is the recyclability of batteries and of wind turbines and of magnets. And there's a huge amount of innovation going into recycling. And it could be that we reach the situation where we've now reached with aluminium, for example, where about 90% of all aluminium that we use is actually recycled. Recycling kind of batteries is much more complex, but it is starting to work. The demand for lithium-ion batteries and the demand for lithium was looking like it was going to go through the roof, but it's starting the curve is being bent downwards through more recycling and better mining technologies. So again, I think ingenuity will allow us to actually develop and mine critical minerals in a socially responsible way, and also recycle them more profoundly than we've done historically. Okay, so that's a great question. So let's have a very, very quick look at the oil and gas strategies through the energy transition. And this chart is very complicated. It dates from July 2020 right through to January, just to the middle of this year. And basically what it tries to kind of represent are 5 oil and gas majors, ExxonMobil at the top, then Shell in orange, Total Energies in red, Chevron, and then BP. And what you can see is that my former company BP is very much the kind of the bottom of the pack. And the tragedy here is that BP and Shell, and particularly kind of BP back in 2020, made a very, very serious commitment to decarbonize and to change its strategy, to reduce oil and gas production. And Exxon did the complete opposite. And you can see how the markets have kind of very, very broadly kind of rewarded the investors for taking a push into renewables and low carbon. Exxon have tended to stick to their knitting around oil and gas and deepen oil and gas exploration and production. And the BP shareholders, and to an extent the Shell shareholders, particularly around the end of kind of around 2024, decided that they didn't like what BP and Shell were doing. In Shell's case, the CEO was changed out. A new guy came in and decided to pull back from the energy transition. In BP's case, stuck with the energy transition, and then the CEO had to resign. You can see the kind of the split away from Chevron back in around the sort of March time 2024, because the old CEO had kind of departed by then. So there are a number of kind of factors which kind of led to this change, but fundamentally what this says is that the market, the capital markets as currently constituted, will not solve climate change. So the companies that lent into climate change, the BPs and Shells and Totals, did not get kind of rewarded in the same way that Exxon did. And actually the one outlier here is probably the one in green, which is Chevron. This chart only dates back, this chart doesn't include their recent takeover of Hess, and the Chevron share prices have shot right back up again. And if you look pretty much on any kind of share price measure, the American companies who have not lent into the energy transition, Exxon and Chevron, have done way better in terms of shareholder returns than the European companies, with BP being the laggard of the pack because it decided to, it lent in more dramatically the transition and then pulled out of the transition relatively recently. The other big factor here is the Russia-Ukraine war. And the Russia-Ukraine war, clearly a kind of a deep tragedy on its own, with all the kind of the lives lost and the kind of the terrible kind of geopolitical implications of it. But also that war has done more to stop the energy transition than probably anything else. And the reason for that is clearly oil and gas prices went through the roof. Energy prices went through the roof. Energy prices going through the roof encouraged inflation. And then inflation made money more difficult to borrow. And most renewable energy projects are actually financed using debt, and it became increasingly expensive. So at many levels, the Russia-Ukraine war was a very, very big issue, halting the energy transition and actually making those companies that continue to invest in oil and gas much more attractive than those that were pulling out of oil and gas and investing in electrification, the energy transition, CCS, etc., etc. So there are a number of factors. There's actually a really good article in the FT today about BP and Shell's kind of failed energy transition versus the kind of Exxon in particular. It's definitely worth a read if any of you read the FT. It talks quite a lot about the personalities of the CEOs involved and why they felt they were doing the right thing, not just from a kind of financial perspective, because unbelievably during the kind of COVID period back in 2020, the market capitalizations of renewable energy companies were actually higher than those of oil companies. Of course, this was a time when oil was, the demand for oil had kind of fallen away. But we had companies like Ørsted, you may be familiar with, the Danish wind company. Their market capitalization of 82 billion at the time was bigger than that of BP's. So these things do come in cycles, but the cycle we're at the moment is that oil and gas is kind of winning over renewables, particularly for these companies that are seeking to transition away from oil and gas, which they've now stopped in their tracks. So it's a sad story. I'll skip this next slide. Just to give you the final conclusion, BP was going to invest 8 billion into renewables and 8 billion into oil and gas. And that was the commitment made in 2020. The pullback this year, in February this year, reducing the capital expenditure into renewables. So that's gone down from about 8 billion, 7 billion here to about 1.5 to 2 billion. And BP, to quote sort of Amy Winehouse, has gone back to black, which for me is very disappointing. But sadly, it's a kind of response to investor demands, activist investors, and in part the failure to execute properly on some of these renewable projects. So that's just a little bit of a cameo around oil and gas companies. They are absolutely not committed to the energy transition. They say they are, they're not. Don't believe them. And it's going to take real government action and, frankly, consumer action to grow electricity demand and to start to displace oil and gas more quickly. So with that, I think my time is up. Thank you very much for having me on. Happy to take any final questions.
Thank you so much. That was very interesting. I don't know if anybody's got any questions that they would like to ask. I can't see everybody's hands. I can start if nobody else has one straight away. So what I was wondering is, obviously, this situation that's happened at the end here is a massive, massive problem for the world. If that companies are not able to transition or are not seeing any, or is making it very financially hard for oil and gas and energy companies to transition away from the fossil fuels to more renewable sources. So I just guess my question was, what do you think the country, the world, society should do about this to try and change this situation?
That is absolutely precisely the question, Catherine, that normally happens at the end of this presentation. So what is to be done?
Yeah,
I think the answer is, I think there is a recognition that the energy transition is going to be slower than anticipated. And that we will not get to, certainly won't get to 1.5 degrees, probably not 2 degrees, it will be somewhere around 2.5 degrees. And that actually what will happen is that more capital will be directed towards adaptation, so adapting to extreme weather events, and also to supporting kind of human migration away from areas. So my anticipation is that we'll kind of bumble along. We'll probably get to an outcome that's not the worst outcome, but it's certainly not below 2 degrees. and countries will have to adapt more. We may start to see some kind of really kind of rapid tipping points around electric vehicles and around electrification, which make it so obvious that this is the better commercial outcome that will displace oil and gas more quickly from the system. So I remain optimistic that we won't end up with a kind of the worst possible scenario. There will be more government and private investment in adaptation alongside mitigation. And there'll be some super big challenges in terms of kind of human displacement.
So that effectively means that the large-scale companies are going to carry on making money and then leaving societies and everybody else to deal with the disastrous consequences.
Absolutely. The Philippines just today announced that it was going to sue Shell for an extreme weather event. So we've got hundreds of those lawsuits around the world, and eventually one of those is going to stick, and that will make a difference and potentially be a kind of a legal tipping point. Again, I don't think that legal tipping point is going to occur in the US. We know it nearly happened to Shell kind of a couple of years ago, when Shell were not accommodating Scope 3 emissions in their considerations around investment. But then that was then repealed last year or earlier this year. So I think that there will be continued kind of legal action and activist action. But frankly, until shareholders get rewarded for allocating capital to projects that are not necessarily going to deliver the highest returns, but one delivers the most sustainable returns, and ones that deliver a lower carbon outcome, because low carbon is incentivized either by carbon pricing or by balance sheets, then I don't think we're going to see much dramatic change.
Very interesting. Does anybody else have any questions that they'd like to ask? Oh, Ben has a question from a lawyer.
Thanks, Dom. It wasn't actually a legal question. It was just a point of interest about a data point that you from earlier on in your presentation. Just about, you mentioned that advanced economists emissions had dropped down to kind of early 1970s levels. And I wonder whether that takes into account kind of offshoring of agriculture, emissions associated with agriculture, manufacture, and also shipping and aviation as well.
Absolutely not, Ben. It doesn't take into account offshoring. The UK has been very proud to announce that it's roughly halved its emissions. So from about a gigaton, well, probably maybe 900 megatons down to about 400 megatons. I would say half of that's come from genuine deployment of low carbon electricity, and half of that's come from offshoring of manufacturing, particularly to China. And China was supporting its manufacturing through coal-fired generation. So it's a great question, Ben. And offshoring to more carbon-intensive countries for manufacturing has had a dramatic effect. Bill.
Hi. I've been very, very interested. Thank you for an excellent presentation. I've been very impressed by the amount of factual information you've got in there. Would it be possible to make this presentation available to other people?
Absolutely, yeah. It's all kind of all publicly available information, so you're very welcome to. I'm sure Kate and team will make this available to everybody who'd like a copy.
Many thanks for that. Yeah.